In this video, let's take a look at some of the differences between a permutation and a combination. In our first example, it says we want to elect 3 officers from our club of 25 people. The first person will be the president, the second will be the vice president, and the third will be the treasurer. So in this case, the order matters. Let me give you an example. If Julie is elected president, that is different than if Julie was elected treasurer. So here are my 3 people: Julie for president, Louis for vice president, and Susie for treasurer. That is different than having Louis as president and maybe Susie as vice president, and let's say Julie gets treasurer. See, these are two different ways to elect those officers. So in this case, the order matters. That is a permutation. In our calculator, if we have 25 to choose from and we want to select 3, we'd put it in like this, and that would be 13,800. And that is the same thing as filling in our 3 boxes. We have 25 people to pick for this first office. Well, if 1 is selected, then we have 24 left. And then if another is selected, we have 23 to fill the last spot. If we just multiply this out, that's also 13,800. Example 2, we want to form a 3-person committee. Now, it doesn't matter if it's Julie, Louis, or Susie, because that is equal to Louis, Susie, and Julie. It's still the same committee. So in this case, order doesn't matter. And that is a combination. We still have the 25 to select from, and we're going to pick 3. And so that's 2,300, a lot less than the permutation. Okay, so when you're counting how many ways there are to arrange some number of items, order matters. That's a permutation. When you're counting how many ways there are to simply group some number of items, order does not matter. That's a combination. All right, let's look at a couple more examples. We have the debate club wants to elect 4 officers from its members of 30. Well, this was just like the previous example. This is a permutation because the order matters. You have 30 to fill the first slot, 29 for the second, 28 for the third, and 27 for the fourth. That is 657,720 ways to the debate club could elect its officers. That is the same thing as 30 pick 4. If you put that in your calculator, you'll get the same number. In example 4, the debate club wants to create a 4-person committee. Okay, so order doesn't matter. This is a combination. So if we have 30 people and we want to choose 4 in our calculator, that's going to give us 27,405. There is a formula for combinations, and that is this. N is the total, R is how many you want to select, and this is equal to n factorial divided by r factorial n minus r factorial. Now, we're not going to really take a look at this factorial notation, but what this does is it multiplies all the previous numbers to 1. So for example, this is a factorial, and you have a button on your calculator, but if I wanted to find like 5 factorial, that would be equal to 5 times 4 times 3 times 2 times 1. And if we put that in the calculator, let's see, 5 times 4 is 20 times 3 is 60 times 2. This would be 120. But we'll just use the calculator and do the combination and permutation shortcut. Combinations with restrictions. In example 5, it says the Young Republican Club consists of 7 seniors, 9 juniors, and 5 sophomores. Okay, so let's see, 7 plus 9 plus 5, I think that is 21 total, right? Because 5 and 7 is 12, plus 9 is 21 total. Okay, we're just talking about a committee. So this is 21, and let's see, order does not matter. So this is a combination, and we want to select 4 in our calculator. That's 5985. How many committees are possible that consist of all sophomores? Okay, so this one is a restricted. Okay, it affects the whole committee because they have to all be sophomores. Okay, so in this case, we have 5 sophomores and we want to choose 4 of them. And so in our calculator, that just gives us 5 different committees. How many different committees would be applied if the club's president must be one of the members? Okay, so remember, we have 4 spots. This guy has to be president. So there's only one president. Now these spots can be any other person. So we have 20 remaining members and we want to select 3 of them. And so what we would do here is 1 times, and then if we put this in our calculator, this would give us 1,140 different committees. Okay, now the next one is how many different committees could be formed if the committee must contain exactly 2 seniors and 2 juniors. Okay, so here's my seniors and here's my juniors. Okay, so let's see, we have 7 seniors to choose from, and we're gonna choose 2. It doesn't matter the order because this is just a committee. And let's see, we have 9 juniors to choose, 9 juniors to select from, and we're going to choose 2. And so we will multiply these two, put them in your calculator. This is going to give us 756.